Hello everyone, today we are going to solve this algorithm question. Let's read the question first. The recurrence Tn is equals to 7Tn by 2 plus n square. Describe the running time of an algorithm A. So we have an algorithm A, its run time is Tn. A competing algorithm A dash has a running time T dash n. We have a competing algorithm whose run time is T dash n. So what is the largest integer value for small a such that a dash is asymptotically faster than a? In this T dash n, we have a variable a. We have to find the minimum value of this variable a, the largest integer value for this variable a such that this a dash is always faster than this capital A algorithm. Okay. So to find this out, let's individually solve these two equations. Okay, and these two equations can be easily solved with the master theorem. Let's first understand what is the master theorem. Master theorem basically says that if you can represent any recursive function like this, Tn is equals to a Tn by b plus Fn, then what you do first, you calculate n raised to power log a base b, where this a and b are coming from this place. This is a and this is b. And then what you do, you compare this value, this entire value with this Fn. So if this Fn is bigger than this, then Fn is the answer. If this Fn is smaller than this is the answer. If both are equal, then this multiplied by natural log n is the answer. So this is as simple as that to remember. Okay, so let's first calculate n raised to power log a, where base is b. So if you see here, a is 7, b is 2, n Tn is equals to a Tn by b plus Fn, and Fn is equals to n square. So first of all, we have to calculate n raised to power log a, and its power base is b. N log, what is a? A is 7 and base is 2. If you calculate log 7 of base 2, that will come out to be around 2.8. You can easily calculate that on the Google. Log 7 base 2. It will come out to be 2.8073. So I am writing it n raised to power 2.8. Now, which one is bigger? N square is bigger or n raised to power 2.8 is bigger? Obviously, this one is bigger. So Tn is equals to theta of n raised to power 2.8. Okay. So this equation, the answer of this equation is theta n raised to power 2.8. Now let's solve T dash n. T dash n is equals to a T dash n by 4 plus n square. Here a is equals to a, b is equals to 4, and Fn is equals to n square. First we will calculate n raised to power log a base b. N raised to power log base is 4 and a is equals to a. Now we are saying this T dash n has to be faster than Tn. It means T dash n should be lesser than Tn. Faster means lesser time, right? So this time complexity n raised to power log 4a should be less than n raised to power 2.8. Now one question that can arise in your mind is that how I am concluding that the answer of this recurrence relationship is this. See, in the question we have to find the largest value of a such that it is faster than Tn. So I have to compare with this n raised to power 2.8. So what we are assuming that this function, the recurrence relationship, the complexity of this function will be more than n square. See, if this value, this n raised to power log 4a, if this is less than n square, then function will be directly n square. But that will not give you the biggest value of a, the largest value of a. We have to assume that this n raised to power log a base 4 is greater than n square. Okay, so that you can get the largest value. If it is greater than n square, then as I told you, you have to compare these two values. Whichever is greater, that is going to be the answer. So that's why I am assuming that the answer of this t dash n is n raised to power log 4a. I hope that is clear. Now we can actually equate this. Log a base 4 is equals to 2.8. I just removed this raised to power thing. Okay. Now how do I solve this log? If I remove the log, it will become raised to power. So a is less than 4 raised to power 2.8, and if you calculate 4 raised to power 2.8 on the Google, it will give you 48.5. So a has to be less than 48.5. Since in the question we have been asked to find the largest integer value, not the decimal value, so the answer would be a is equals to 48. That can be the maximum value of a. Okay, so the answer, the largest value of a is 48. If a is less than 48, then this t dash n will always be asymptotically faster than tn. Okay, I hope that's clear.